Assalamualaikum warahmatullahi wabarakatuh. My name Ahmad Imran Ashraf bin Osman. I will explain about the introduction part. For the introduction, this project we will build and install a PID controller based water level control system. We use a MATLAB Simulink model to compress the system. A mathematical model of the system will be developed as well as a block diagram. The PID controller again simulates using the manual PID controller and open the loop system and the PI and PID controller. The PID controller can be fine-tuned to operate even better than the manually tuned controller. So for the problem elaboration, in this water level system, the DC motor acts as an actuator and control the water flow inside the water tank. Before the block diagram is simulated through MATLAB, the DC motor transfer function needs to be obtained. Okay, this below are the equation that are required to calculate transfer function of the DC motor. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sulaiman Mukasim. My matrix number is 882018. Today I will present about problem elaboration. For the table is the value what we get in our question to done this project. First we do the Laplace transform of a matter currents equation. And second, for the first equation apply to motor, we get Tm equal to theta ms gt s square plus bts. So the Laplace transform for electromagnetical equation, we get this. And for all what we get above, we can calculate IA from the question 2. We key in the question 3 to question 2. And next we insert equation 4 and 5 to the equation 1 above. And for this calculation, we assume ZA equal to JT S square plus BT S multiplied by RA plus LAS. For the VA, we divide the theta m over VA, and the final we get this. So for the value JT, we already have their value for get JT and BT, so we just key in here, and this what we get. And after that, we just key in the value what we have to QM over VA equation, and the final we get this. This is our block diagram. Okay, next is for the tank calculation. This is our tank and the information over there. We just key in the equation over here, and the final we get has S over Q in equal to 1 over AS plus A multiplied by 2G hash. For the pipe is 0.2, the diameter. We get value A 0.0314, and for the pipe is 2.0, we get the A 3.142, and this value we key in this equation, and the final we get this. And for the Ziegler-Nicholas tune, we let Ki and Kd equal to 0. Tf, we do this calculation, and the last we find the value of S, and the value S what we get is S equal to plus minus 0.153, and the value K what we get, K actually equal to KCR. For this calculation we get 0.313, and PCR we get 2 pi over 0.153. So the value of Kp, Ki, Ki, Td for the Pi, Pid is over here. What we get, we just key in the value what we get in the formula and we get all this.
Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarif. So I'm from group 12. Okay, today I would like to explain about to do simulation about my water tank level simulation. Okay. So first thing first, we need to do this in MATLAB, as we know, because we need to do the simulation here. So we are using MATLAB because it's more easy for us to design our simulation. So the first component we need is step, and then sum, gain, transfer function, marks, and our scope. Okay, so this is our P controller for the simulation. So we insert here in the gain. This is our gain. So let's run it. Okay, it's not here. Oh, here. Okay, so this is our our result, which is the x parameter is time, and no, the x is height, and the y is height, and the x is time. Okay. So this is for P, and then we go to this, this is PI controller. As we can see here, we have step, sum, gain, and then this is integrator, sum again, transfer function, and marks and scope. So here we put it gain for this is what we call wait. This is proportional, this is integral. Okay. So after we input the calculation that we made, so this is our result for PI controller. This is P. Okay, so this is for PI controller. So it looks the same from P controller. So the next one, we move on to the PID controller. This is the best part. So this is the this is the proportional, this is the integral, and this is the derivative calculation. Okay, so the component is the same, but we add here the derivative calculation, which is 0.964. Within the within the simulation, we will get supposed to be, oh wait, what happened? Okay, so we are looking at, okay, this is the graph. So for PID controller system, this is our result. It just looks the same, but the next one, this is the whole PID control system. So we have PI here, PID here, and then the last one is tuning here. Okay, for the tuning, it's a little bit different. The result will be a little bit different because we input the tuning here. So just we look at here first. Oh no no. So the PI is same. PID also same. This is the tuning. The tuning is different. Okay, this is our result for tuning. So when we combine it, the three of this, after we combine it, so this is our result. This is our result. So the the blue line here is from PID, and the purple one is from the tune. Okay, so the next one is, okay, this is our automatic. The parts is manual. This is our automatic. So here we got our step plot. They're different between the response because this is plotting. So as we can see here, our water level is rising, and then it can stabilize our coding and our in our simulation. Our calculation is successful, and the simulation is success because the water level can stabilize the range. Okay, so this is our automatic. No, this for the rise time, different. The automatic and manual is very different, which is the manual takes 10.3 seconds and the automatic takes 0.488 seconds. For our settling time, 138 seconds and 72.4 seconds. Our overshoot 9.27%, which is the requirement say must be less than 10%. Okay, so we did it, and then our peak is 1.09 and 1.93. Our gain margin 39.2 and 6.38. Phase margin 64.5 and 22.8. So our closed loop stability is stable. So this is all from me. This just to highlight here, we do it open loop for P, PI and PID, and then this is the closed loop one for the whole PID control system, and then this is our tune. Okay, thank you.
Okay, for the conclusion, the result of this study show that PID controller can be effectively used to control water level in tanks. The PID controller can be tuned manually or automatically to achieve the desired performance. The automatic tuning method can be used to achieve even better performance than the manual tuning method. That's all for our group. Thank you.